So you've been trying OpenClaw and you have noticed that the memory system does not work always. It forgets things. And if you actually have work with OpenClaw beyond the X-Hype and the Mac Mini guy, you have noticed that it's not perfect. The defaults of OpenClaw are not... they are good for a prototype, but they are not production ready, and indeed they are not that helpful for long run periods of time. Because, but let's be honest, I mean, if you got one only file, okay, one only file with all your memories, which is called the MEMORY.md, you can already realize that this is not a good strategy. Because your life, if you want to really have this long-running assistant that remembers everything and your life and whatever you want, this has a limit. And this limit is called 250K context window size. Okay? So there is a hard limit. And the longer this file, the more expensive it also gets. So you want to manage this in a way that plays in your favor in the sense that it does not forget the things you want it to actually remember, and at the same time it does not increase the cost too much. Okay, so this is a problem that involves two concepts. Okay, the first one, okay, it's called storage strategy. Well, let's simplify it. Storage and retrieval. Okay, if your OpenClaw forgets important things for you, it means that you can have a storage problem or a retrieval problem. Now, what are those? Basically, the storage problem, if you have a storage problem, OpenClaw, it's not storing the memories when it should do, right? How does OpenClaw works as a default, right? So OpenClaw, okay, as a default, you are talking with it in your chat, okay, you have this and you have that, and when it reaches the context window size, okay, when the context window reaches the limits, okay, when it reaches the limits, what it happens, it compacts, okay, compacts. And what happens when it compacts? That it tries to flush into memory all the things you have been talking with your assistant in all the conversations. So if this conversation grew like a lot, okay, you're gonna have a problem, because normally the compaction summary, it loses detail and loses enrichment because it tries to be a summary. It's not like the assistant is storing into memory each time it answers you. No, it stores into memory here and tries to do a best effort compaction and a summary and flush it into memory. Okay, the thing is that this is a bad strategy for storage. Okay, why? Because the compaction does not store all the things you want, and also I don't like having long-running sessions of chat. Okay, because it grows the cost too much. So what I prefer to do, it's basically, this is the first strategy for storage, is to set a cron, a scheduler, okay, that runs each X minutes. In my case, it's 10 minutes, okay? And each 10 minutes, it flashes into memory 10 messages, tries to understand what's going on. It's like another agent, okay? So you could have your agent here, the one with who you are talking with, okay? This is you, and you are talking with him. The thing is that there is another agent here, this one, okay, that runs each 10 minutes, looks at the conversation, okay, at the latest 10 messages, okay? So you've been talking with the agent and it looks at this and summarizes those 10 messages, 20, sorry. Why is this a better strategy than just hoping for the compaction to produce a good summary? Because you are scoping the problem, you are narrowing the problem. Now AI doesn't have to like summarize a really long conversation where the attention has gone to another place, because if a conversation is really large and you've been talking and talking and talking, AI, at this point, AI is thinking about the current problem. Maybe here you're talking like, can you produce a YouTube video script for my channel? And maybe here you were talking about, can you please, I don't know, make a research about current AI jobs, right? And maybe you want the AI to remember this and more things that happen in the middle. But when it reaches this point, AI is thinking about this, not thinking about what happened at 200 seconds behind. It can, but you are like trusting it too much. At least the current AI models will not produce that good results. So that's why this cron that runs each 10 minutes helps a lot, because you are scoping the problem. You're scoping the problem to 20 messages, okay? And this, okay, these 20 messages, this cron, I've set it up to only flash to memory, the markdown memory file, the main memory file, only the most important things. This is the next point. The MEMORY.md, okay, the MEMORY.md should not contain all your memories, okay? This is not scalable, as I talked about before. So you want this agent to only flash into here important things, like indexes. And normally here, what I use it for are like indexes to other memories. I use it for really important system things, like system environment, like what schedulers we've set up, how the system works. Because if I want to fix something about the system, I don't want OpenClaw to forget about it, right? I don't want OpenClaw to forget that there is a cron logger that runs every 10 minutes. I don't want OpenClaw to forget how the memory works, because when I want to fix something, I need it to at least know it exists. So as a general principle, just store indexes, system things, and things that you want at least the AI to know they exist, okay? Like, okay, maybe it doesn't need to remember that you go to the gym 5 times a day, and your leg day is the Thursday, and your chest day is the chest day. No, maybe it just needs to know that, hey, Matthias goes to the gym 5 times a week, or tries to, and here is the index to the specific detail memory that talks about this area of my life, okay? Maybe you don't want AI to remember every YouTube video script you've been doing and all your YouTube ideas, but you want the AI to remember that you have reports about YouTube in this folder. That's what MEMORY.md should be for, like to let the AI know something exists, okay? So now we've talked about 2 things already. We've talked about the cron logger that runs every 10 minutes, and about what should go into MEMORY.md file, okay? Now, this logger, I told you, it only flashes important memories into the main memory file. What happens about the other memories? This is where the memory structure comes in. And we are only talking about the storage here, okay? We're still not talking about retrieval. So basically, as we don't want all the memories to be in the MEMORY.md, we want it to be scalable. If you want to have this agent running for years and years and years and produce memories and people and events, and I went to this conference and met these people, and in my job this person, and my job and whatever, and my pets, and I went to the vet, and you can be talking about all things. So here enters a practice that you are probably already doing in your personal life, that it's basic folder structures. So you're going to set up folder structures for different areas of your life, okay? I recommend you, for example, having a personal folder, okay? Personal, professional, and this one was personal, professional. What was the other one? I don't remember right now. Personal, education. Because if you go to the university or to a master, or you are learning continuously, I think this is a really decent start. Now, if you want more structure, you can, of course, add here more folders. But for the beginning, I recommend you these three, because they cover already a broad areas of your life. So in personal, you will want to store people and your problems, maybe. You want to have the AI as a coach, your routines, your behaviors. I don't know, whatever personal things you want AI to remember about you, okay? Then in the professional, here you can store projects, your job, and any other professional clients if you are entrepreneur, okay? All the professional life, and in education, if you go to the university, some courses, and whatever, you know. And now, if you want to, for example, store reports, documents, legal documents, I recommend you doing, this goes into memory, okay? A folder called memory. This goes to memory. And adjacent to memory, you should have a documents folder, classic folder structure you can have. And why not inside memory? Because you don't want the agent to remember specific documents. This is more like resources and things like the agent uses for building things. I don't know, like legal documents, research analysis, right? If you have a YouTube channel, this is something I do with my AI, that I tell it twice a week, do a YouTube analysis of my channel, and it does an analysis of what videos perform well and what not perform that well. And I also use it for other things. But so this is a scalable strategy about memory, okay? This is scalable because now you are not putting all the X here. You're not putting all the X here. I'm gonna draw X. But you are dividing them into different boxes that then your OpenClaw here can query, okay? Now, how does OpenClaw query memories? It has one tool, okay? Two tools. The first one, you tell explicitly, like, read this file. Okay, it goes to a specific file named whatever.md and it reads it, okay? It's a really rudimentary tool. The other tool that it's the default strategy for OpenClaw is the memory search. And this tool is basically so each time OpenClaw stores into memory, okay, store something here, it generates embedding vectors, okay? These embedding vectors are stored in a database, okay? So embedding vectors, for those who don't know what they are, it's basically you got a document. This document is split into multiple chunks, and each chunk is assigned a multidimensional vector, okay? X, Y, Z, blah, 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 X, X, okay? And each one embedding vector. Why this embedding vector, you may be asking? Well, these vectors capture semantic meaning of the specific chunk, okay? So These embedding vectors are stored in a database, okay? Are stored in this database that the memory search uses to retrieve semantic. So, the memory search tool retrieves by meaning, not by key or by searching into specific folders. OpenClaw does not search. Like goes into each folder to see what is there unless it needs to, but normally it uses this memory search tool that goes to this database, okay, and it performs a semantic search, a similarity search, okay. You got a query and it goes there, okay. So this memory retrieval strategy is the one that OpenClaw comes with. It's okay. I mean, personally, I've set up Cognee. That it's the other one I wanted to know about. And Cognee, instead of being like this semantic search, Cognee it's a graph database. So a graph database works with relationships. Okay, this person went to this event. This event is about AI. AI, me, I like AI. I like AI, and AI relates to, I don't know, LangChain. So you know, you see that this is like, by a structure, it already captures a lot of meaning. It's a different way of storing data, okay? Instead of relying only into blocks, these blocks that are arbitrarily split, okay? You try to capture semantic data in with the relationships, okay? So how does Cognee work? Each time you text the AI, okay? Each time you text and say something, this text goes to the Cognee, okay, memory as a query, and Cognee runs an AI, an internal LLM model, okay, an LLM that tries to go here, and then it goes here and capture like the relationship, and then this LLM reasons about it, okay, so it thinks about these specific relationships, and the LLM, this LLM from Cognee responds here, okay, and appends that to the to your AI assistant message. So it was some attack like Cognee mem or something like that, and in Cognee mem it writes whatever found in the database, and then it comes your LLM response. Okay, that's how Cognee works. This is another strategy you can apply. Personally, and honestly, Cognee has not produced really good results yet, because this query, it's context agnostic. This query here does not capture like the context of the conversation. So if you say here, can you check? Like, can you check? You already can see that this is not a really good query for this database, because what the LLM is going to bring. Can you check? What does it mean? It means nothing, right? It loses the context, right? So that's why Cognee has not been working really well. Maybe it's because I've not configured it decently. Maybe there are some configurations you can do, but yeah, just so you know how the drawbacks of Cognee. So now, finally, so you got all of this, right? So the thing is that you got all these memory structures, and you have these people.md and problems.md and routines.md. What happens if you run this agent for time and years and years and years? These files grow exponentially, okay? So you are going to have 3,000 lines files. which goes back to the initial problem of storing everything in the memory.md file. We don't want that. So I set up another cron, another scheduler that runs weekly, okay? Runs weekly. And this AI, because it's an AI, goes to each file here and sees if the file is already too large. Basically, it checks if the file goes beyond 300 lines. This is my threshold, okay? 300 lines. And if it goes beyond 300 lines, basically the AI is going to split the file. How it's going to split it, because it's important. It takes the file, okay? It takes the name and creates a folder with this name, okay? So creates a folder with this name. So before, I don't, my letter is horrible, sorry. So it creates a folder, and in this folder stores as many files you need. It tries to do a best effort division of your file, okay? So maybe this file talk about people. So now you have a people folder, and now instead of having only one file for all people, maybe you have one file for your people at your job, okay? People at your job, a file for people at your university, people for you understand, right? So this is another strategy for scaling memory, okay? Because you have to think two steps forward, not just think that. Not just to think that, okay, just because I'm storing into different folders and each folder contains different files, I'll call it a day. No, you will need to set a scheduler that runs weekly and tries to make a split of the files. So I think this is pretty much how my OpenClaw right now works, and it's working pretty well. I think I'm not leaving anything behind. So yeah, I've talked about the flash. This is the flash, but it's not. I told you this does not work well. I told you about the Cron logger that stores memory each 10 minutes, okay? And this captures 10 messages over your conversation and stores the important bits into the memory.md and stores the rest into the memory structure. Then OpenClaw, this is the retrieval. OpenClaw retrieves from these folders, okay? And you store into memory.md file, indexes, system decisions, and anything that you want the AI to know that at least it exists, okay? So this is the retrieval. It uses a memory search tool that searches by similarity into a vector database, okay? And here, this this clutter thing, it was the GraphDB, okay? So this is another strategy, and one specific implementation is Cognee that uses an LLM that queries this database for each query and appends that memory into the AI message, so the AI can generate tokens based on the Cognee memory result. This does not work well when you got generic messages like "Can you check?" Okay, it needs like more context, because it only reads your message, your latest message. So I've already set personally. I think I talked about everything I wanted to talk about. I also set more schedulers for example, YouTube. Okay. So I set schedulers to do report an analysis on my YouTube channel. I've set schedulers to research about AI trends and news. And all of these things are stored into the documents, okay? Here. So I know they are there, and and AI also knows they are there because of the memory indexes, okay? With these principles, I think you are good to go. This is the best life hack I can talk about. the 10 minutes AI that it's looking. Why a cron? Okay, this is important. Why a cron and not a heartbeat? Because OpenClaw has two things. Has crons and heartbeats. Okay, it has crons and it has heartbeats. What's the difference? What's the difference? Crons run on a schedule, okay? So every Monday at 9 a.m., okay? This is on a schedule, the first difference. Heartbeats, well, I'm gonna write it here. So every Monday at 9 a.m. Heartbeats run each X quantity of time. So for example, each 30 minutes. It's not the same, okay? If you want something that it's precise, you want a cron. If you want something that runs each X minutes with a frequency, you want a heartbeat. Now, why you would want a heartbeat? That was my question. So the special thing about heartbeats is that when you are talking with AI, okay? So when you are talking with AI, a heartbeat basically is a whisper, okay? So here, the heartbeat would whisper something to the AI, okay? And it would say, remember to flash into memory, for example. Remember to flash into memory. And then AI reads this, okay? AI reads this and says, I have to, and has the context of the conversation because it happens in the middle of the conversation, okay? And then AI responds normally here, okay? So it's like this whisper that goes into the context window of the AI, okay? So the context window of the AI, this is your chat, and here has the whisper from the heartbeat, the chat, and the good thing is that it has the context of the conversation. So knows what you are talking about, okay? It knows what you are talking about. So it can perform better decisions. So for example, if you want it to flash into memory, this was my first thought. So if I want AI to flash into memory, I just have to create a heartbeat that tells, hey, log into memory. What happens? This is expensive, okay? Because if the conversation grows beyond 100K tokens, this is basically asking AI to predict the next tokens for the previous 100K. So you know that you can see that this is quite expensive already. So that's why I set up a cron, because I don't want AI to know the context about the conversation to flash into memory. I just want it to read the latest 20 messages and to flash them into memory if they are not in memory already. So it does not need the context. So a cron does not have context. It runs blindly, okay? So in the case of the cron that executes every 10 minutes, reads 10 messages, 20, whatever messages you want, and flashes them into memory without needing any extra context from the conversation. Imagine you have more than 100K context window conversation already. Generating the next tokens here for this 100K, it's really expensive, so you don't want that, okay? That's the difference between crons and heartbeats. Heartbeats can be useful if you want them. I can't think about an example right now, honestly. But yeah, just so you know the difference, this is like a whisper into the current context of the AI, and this is just an AI that wakes up, does a job, and goes to sleep. That's the thing. Yeah, so that's how my OpenClaw works, and that's how my OpenClaw at least remembers pretty much better everything that I talk about with it, and it also does it in a scalable way without having this clutter memory.md file that grows and grows and grows and never stops growing. So yeah, with these strategies, you can apply them to OpenClaw, MiniClaw, MaxClaw, whatever claw you want, any AI system you are designing. This is context. Management. Okay, this is context engineering, so it can be applying whatever you want. This is for long-running agents. Okay, and you have only processes. For example, N8N. N8N. It's a tool that it's stateless, let's say. It executes processes. I mean, it can remember things if you connect it to a database and do this and do that, but this is more what I talk about in this video for long-running agents. So now you're good to go. So I hope you like it. See you soon, and let's stay connected.